Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
And we are back. Okay, our journey continues. Exciting stuff. Okay, so we came about a very interesting data set within Google Earth Engine, which is this one here, this global settlement characteristics data set. I must confess I didn't know of it, and yeah, I was not aware of it. If I knew, I would have for sure have used it. There's definitely some value to in it, but sadly, this is only a once-off image. It's only image. It's not an image collection. It's only for 2018, which is given 4 or 5 years ago. But it's nonetheless, it's very informative and very interesting. So as I said, we're working with this image within Earth Engine. And so we basically captured the image, we displayed the image, and as I said, it looks very interesting. So I want to continue working with this specific image. Yes, I understand that there's issues relating to it's only available for 2018, but I said this video tutorials on Earth Engine is more than just the relevance of the data set per se. It is working with these data sets, learning Earth Engine, learning coding, learning what we could do with this, because you can apply it obviously to many other data sets. So we basically ended our previous video tutorial with this image, where we then presented this data set for my region of interest. And it identifies very accurately the main towns or the towns within my region of interest. And then with each town, and this should be, you should be more than familiar with this town here where I stay. Within this town, there is pixels or locations with various colors, and each of these colors represent a form, a land use form, and that you'll find on the landing page of this particular data set. And there it go. As I said, greenish colors is grassy area, blue is water, yellow and reddish is orange, and red is build-up areas, residential, and then pinkish areas are non-residential buildings. So the beauty of this is, as I said, it just not only presents the buildings, but it actually also presents the height of these buildings, which is unfortunately not the size of these buildings, but remember we have calculated those previously on stuff. So yeah, so this is a very interesting stuff. But yeah, as I said, we get to this specific image. Now this seems quite a busy image. It's not a yeah, it's very busy. So what we want to do is to sort of generate a bit of descriptive statistics, a bit of statistics on this, because that I think could summarize this image better than if we try to just visualize the image and stuff. You can see there's definitely quite a lot of red. There's a lot of orange here. There's some orange there. There's reddish here. There's pink there. Now, what is pink again? Let's have a look and see what that pink is. Smaller than 3 meters, I would assume. So that would be 21. So if we use our inspector and we click on this, what value would it give us? 23. So that is, we go there, 23 build-up spaces between 6 and 15 meter, building height between 6 meters and 15 meters. I'm not sure whether that's entirely accurate, I doubt it, but yeah, as I said, it's we need to go and have a look in there in what was 2018 there. Um, okay, you'll see if I click on the black, the vast majority has got a zero value. Now, zero value doesn't reflect here at all. It's this low vegetation surfaces, medium, high vegetation. So actually, we should clip it so that it doesn't display the zeros, because that's land, agricultural land, etc., etc. Anyway, anyhow, okay. So let's continue with this image because I said it's fascinating. It's very interesting. It looks fairly accurate in terms of identifying and isolating build-up areas. The content of the build-up areas, one might just, and ah a little bit, say it's not building 6 meters, it's 2 meters, whatever. But nonetheless, it fairly accurately identifies and isolates towns, urban areas, buildings, and the like. Okay, so there's a little town here. There's some, these are farms. I presume these are farms that they, okay, let's quickly put it on satellite and see what, yeah. So if we zoom in, yeah, those are farms. See, that's a farmstead, that's a homestead. So um, it does identify those are homesteads as well. Let's quickly go and, okay, so you can see there, it does identify these homesteads quite accurately. I said, this is a very, very nice data set, I have to say. Now, this is 2018, the image itself, and the satellite image is, I think, 2023 as latest. So it may not uh, perfectly overlap simply because of the difference in time. You see, there's a little homestead there as well, farmstead there, and you can see it sort of mimics. And you can see also the scale, né? The scale is 10 meters, I think it's a scale. Let's have a look and see what was the scale again. 10 meters, yeah, there's the 10 meters. So it's a very, very high resolution image. And that's why, again, why it's very, very useful. You can see there. So overall, I think this is a very fascinating. It overlaps, it overlays this down almost to the T. There may be areas that it doesn't sufficiently cover simply because of the time delay from 2018. You may not see it there. Let's have a look and see in this town here, that pink area there. Let's see. See, that's definitely not 6 to 10 meters. You can see there are some areas that it doesn't properly. Um, see, there's some places here, but that's are sort of one level buildings and things like that. That's a T. That's a golf course. So obviously there's a little bit of, you can see there's some open space here. There's some jetties. There's some, you can see there's some newer buildings there that's post 2018. Post 2018. So it's not that the data set is necessarily um, um, wrong. It's just that it's sadly a bit outdated. And that's why I said it would have been nice to actually take this methodology and just run it year after year. Because if you can do this once, certainly you can do it again. Oh, that would be the theory anyway. That would be the theory anyway. Okay. Point being, I like it. I like it. I like it a lot, as is said in the movies. Okay, so first thing that I want to do is to generate basic descriptive statistics. So when we do articles and things like this, and when you work with data, the first thing is sort of to look at your basic descriptive statistics. So what are those statistics? Those are basically, we're looking at measures of central tendency. That's typically your mean, median, and mode. Then you typically look at your minimum and maximum values. We look at your range, standard deviation, coefficient of a variance, and things like this. That summarizes the data of your variable quite nicely. Okay, so here we've got a variable, and that variable is build characteristics. That's the band. Okay, that's the band, which is this thing here. So you see, there's the name of the band, build characteristics, and then it has categories here. Then it has categories. So we want to see which of these categories are dominant. Okay, we can do it with the mean. Which of this is the one that occurs on average, the one that occurs in the middle, the one that occurs the most, etc. And the standard deviation and all these sort of things. It gives us a nice summary of this. So first what we all have to do is to, sorry, where am I now? The first what we want to do is to, once we've displayed it, okay, once we've displayed it, we want to calculate the descriptive statistics. And there is the descriptive statistics. Okay, so I'm going to generate a mode. Okay, I'm going to generate a mode. I'm going to generate a min-max. I'm going to generate a mean. It's going to generate a median. There's my mode. We can put it in there. EE reducer mode. I don't know why it's, okay, let me do that. See if that works. Forward slash, and I'm going to put a comma there, and I'm going to put a forward slash there. Let's see if it works. Yeah, it should be working fine. I'm just going to delete that because we don't need it there. We're just going to do it here. Okay, so we're going to calculate the minimum maximum, because from the minimum and maximum we can calculate the range. And then we're going to calculate a mean, median, mode, and we're going to calculate the standard deviation. I'm going to calculate it for my region of interest. My scale, that's the spatial resolution, is, as I said, the spatial resolution is 10 meters, and maximum pixel is maximums that we can do, and we're going to have to print it. Okay, so that, sorry, let me just delete it. That's duplicate. We can calculate the statistics for each band. Okay, now just bear in mind the band, the image that we're using is build, which is my image build here, which is my image, and this band selected. Now, if you had multiple bands, you will put band one. So let's say you do Lancet or Sentinel. Okay, then you'll have to do this for each and every band. So you'll have band 1, band 2, band 3, and so you will do that for each and every band. Okay, so if there's multiple bands, if there's 13 bands, you'll have 13 of these things. You'll have 13 of them. Okay, so there will be a band 1, a band 2, and then you'll have a build descriptive statistics for each of those bands. Okay, so just bear that in mind. The more bands you have, the more code you will have. You don't have one for all of it. Okay, so let's have a look and see. I already know there's a problem, but anyway, okay, let's go and see if we have a problem. Okay, so there's our descriptive statistics. There's our descriptive statistics. And you can expand on this. Surely you can expand on this to include, let's say, skewness and all these things. We'll see if we can do that in a later video. Okay, so our descriptive statistics, our maximum is 24. As we look and see, our maximum is, in fact, 25. Why is it? It's most probably because there's nothing. One of these, there's nothing. So it only stops there. So most probably non-racer bigger than 30, there is nothing. Which most probably is true. Knowing the area, there's not any scape here. Minimum is 0. That's true. That's all the black that we've already showed. And now these values, the mean, median, and mode, are obviously skewed because you can see, and I don't want to say exact percentage, but the vast majority of this region of interest is black, meaning 0. So therefore, it will be skewed. So you almost have to exclude 0 and then redo this descriptive statistic, and we'll do that a bit later, where we're going to generate a new a masked image, and then gonna recalculate the descriptive statistics. The sheer volume of the zeros here just skews all of these numbers. Okay, the sheer, so we must exclude all values of 0 and only starts from 1. Okay, because we want the descriptive statistics for these categories, not for 0. And at the moment, it includes 0. Okay, so just bear that in mind, that we need to make a note there and say, okay, we need to compensate for that 0. So that's something to bear in mind. Okay, so that's my descriptive statistics. We've calculated that, and we can expand on this. We'll do that a bit later as well. We can expand on these descriptive statistics, but in general, that's your basic descriptive statistics. That's your basic descriptive statistics. Okay, all good with that. So it's quite interesting. Well, let's say it's not saying much, simply because of the zeros. It's not saying much at all. So we need to compensate for that. Okay, so we're going to do a mask image. Okay, let me just save there. Remember, please remember to save, 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 save. Okay, so now what I also wanted to do further to the descriptive statistics, I want to calculate the unique values. I want to generate a unique values report, meaning I want to understand how many of my cells have zeros, how many of my cells have ones, how many of my cells have twos, etc., etc. And you can simply just multiply that by 10 to get to the square meterage of each of these characteristics of each of these characteristics. So I want to know in my region now, how many pixels are this? How many pixels are this? How many pixels are this? Because then I can just multiply it by 10 to get to, in my pixel, total, how many land, what is my geographical surface of, let's say, buildings, residential 3 to 6 meters. That's what we call a unique value, because these 1, 2, 3, those are unique values. So I want to calculate how many pixels are there that have a value of 1. How many pixels are there that have a value of 2 and 3 and 4 and 5 and 6, etc., etc. So that's what I want to calculate, okay? And you call it a unique value report, okay? You can do it very straightforward in QGIS, but we're going to do it here in Earth Engine. Okay, so there we go. Let's have a look. Okay, so remember we've done our descriptive statistics. There they are. Although not of great value, there's certainly some value to it if we do it properly. Okay, so next thing is the unique values report. So we're going to go our unique values report. We're going to create a variable which is called unique values report. We're going to use our image, which is built. Okay, where does that come from? Remember, there's our built. Okay, built is our data set and focusing on the band. Okay, and it's clipped for my region of interest. So that's built. Okay, remember we use built for everything. Built to calculate our descriptive statistics, and now we're using build that data set, that image, to generate our unique values report. I call it unique values. It's built, and I reduce it for my region, and I'm doing a frequency histogram for my region of interest. Scale is again 10 and maximum pixels, and I'm going to print it. Okay, so I'm using a reducer. Okay, I'm using a reducer, and I'm going to create a frequency histogram for my region of interest for that image, okay, for that band. Okay, remember again, if this is per band. Okay, if you have multiple bands, you have multiple of these things. So let's see how that looks. Okay, so I just click run, and it will display. And there is it. There it is. Okay, so zeros, you can see the CF volume. 0 pixels is, what's it, 43,910,710. So many pixels have is value of 0. 43,910,710. You can see the CF volume, it dwarfs all these others. And that's evident from from the image. So that's why we have to exclude 0 actually. How many ones? 26,730. Now, what is 1? Let's go back. 1 is open spaces, low vegetation surfaces. Open spaces, low vegetation surfaces. Okay, 524 is, you see, there's no 25. See, there is no 25 here. So that's why our maximum is 24. There is no 25 here. Which is the lowest value? 481, 476, 297. What's 4? 4, sorry, not 4. Yeah, 4. What is 4? 4 is open spaces, water surfaces. So that's only 297 pixels that have water, etc. So what? How many houses? Let's small houses. Building height less than 3. There's 11, 12, and 13. 11, 99, 100,000, 12, 15,000, 13, 20,000, 11, 12, 13. Let's have a look and see. 11, 12, 13, 14. That's high rise buildings. 14 is very little, which makes sense. Okay. 21, 660,004. What's 23? 23 is building spaces 6 to 15 meters. I wonder. This is height above sea level or actual building sizes. Anyway, number 3 is also quite a lot. Number 3, 99. 11 is 99,000. Number 3 is almost 50,000. What is number 3? Open spaces, high vegetation surfaces. Okay. So there's our unique values report. As I said, it gives you the summary of the number of pixels of each of those categories. Okay, so the number of pixels for each of those categories. And if you know your spatial resolution, you can calculate the surface that it occupies, the surface that it occupies. Okay, so that's quite neat. So now I've got my descriptive statistics and I have my unique values report. And as I said, that is quite interesting stuff. Now, if we exclude the 0 here, that's 0, that's 43 million, then we will be able to calculate the mean and all these sort of things. Okay, so yeah, so that's, I think, again, quite interesting information to know. And again, it's not just for this. We can now apply this script, this method to any of our data sets. And lastly, what I wanted to do is to say, okay, now let's put this frequency histogram, this frequency distribution, this histogram. Let's put it on a nice little image. Let's display it visually. Okay. So this frequency distribution is displayed on this histogram. Now this is okay. So you see 43, 943, 910. You see that one. Number 1, 26,730, 26,730. You can see all of these obviously will be almost under 0 access simply because of the sheer volume of this. And again, that's why it's important that we exclude 0. It's important to us to get you a total of the area. So that's important, for sure. Without a shadow of a doubt, I wouldn't ignore it, but if we just want to look at areas excluding that, then we need to do that. We need to exclude it. So there's my let me just quickly there's my script. There's my script. So I'm going unique value count. So I'm creating a new variable and I'm using unique values. What is my unique values? This is what I've just calculated here, the frequency. Okay, and I'm using it for my image. Okay, so again, basically repeating what I've done there. Basically repeating what I've done there. Then I create an array. Okay, I list it. I list the values, the unique value counts, this one here. I list the value and then I use that to generate my histogram, this one here. Okay, so that's the the histogram I generate. Now you can go and change the you can go and change the title and all of these sort of things, colors and all of these things. But for basic, it should be more sufficient. So I create a count. So I count how many of them. This is a variable, which is my unique values for each of these bands. Okay, for each of the bands. Now there's only one band, so you create unique values, which is the frequency distribution. Okay, so I do that, and then I create from that's my variable that I've created now, the counts, and then from the count I create an array. Okay, I create an array. And then I take this array and I basically just do um, a histogram. You can see there's the array itself. Okay, I create a histogram and I print the histogram, and that will give me this. Now, as I said, we need to, for a more professional look, we need to exclude the zero. Otherwise, why display something like this? It's just not any good. And here's gives you idea of the sheer magnitude of the zero. And there's our descriptive statistics. Okay, so let's pause for there. Some good news. But I said in most of my other video tutorials is that, you know, this leads now into the next topic and the next topic and the next topic. So in the next one, we most probably will see what we can do regarding the zeros. How do we compensate for the zeros? Almost do one with zeros and other one without zeros. Okay, but just to summarize for this one, we've taken our image, and from the image we generated our descriptive statistics. Then we created our new unique values report, and then we display our unique values report via a histogram. So that's the three things that we did for this video tutorial. And again, we just getting information. We're just taking this image and we're just dissecting it. We're just analyzing it. We're just investigating, analyzing, getting information out of this. And that's the beauty of it. So much we can do. Great. Now, yeah, that's good. I think that was, I think, to be very honest, very interesting. And I don't think in any of our video tutorials have we done this up to now. No, I don't think so. I think this is the first time we actually have done this, where we actually generated descriptive statistics, unique value reports. Histograms we've done, but not in this context. So this is quite new. So it's a new data set. And with this data set, we've now generated some information that we haven't done previously, but we can now apply this to, you know, any of our previous data sets. Now, just bear in mind, in this case, there's only a limited number of unique values. Soon as we have individual or really unique values, then this list will go very high. But yeah, with this categorized data, doing unique value reports actually quite nice. Okay, anyway, let's save. I think that's it for this particular video tutorial. Yeah, I think so. Let's park it for there. Thanks everybody for joining me. Much appreciated. For those that are loyal supporters, subscribers, and for those that press those like buttons, please, thank you very much from the bottom of my heart. Really appreciate it. This journey is not just about me, but it's for all of us, so we can master this field called remote sensing. Very interesting stuff. So with that in mind, please remember to like, subscribe, share the video. I'm in your hands. I'm in your hands. I'm in your hands. And yeah, I'll see you on the other side.